Scroll through any tech feed right now, and you'll see an endless wall of high-wattage chargers promising to cut your charge times in half. Take the Tranyoo US8. The box is throwing some heavy numbers at us: 120 watts of power, GaN technology, and global voltage support. The question is whether this single block can realistically replace every other charger you own, or if you're about to pay for capacity your hardware will never actually use. To figure that out, we have to look past the raw wattage number printed on the side of the casing. What actually dictates your speed is the handshake. Every time you plug in, your phone and the charger have a digital negotiation to decide exactly how much power is safe to pull. This chart shows how the actual impact of a 120-watt upgrade depends entirely on which device is on the other end of the cable. If the hardware can't complete that specific handshake, the extra wattage stays in the wall. If we tried to push 120 watts through an old-school silicon charger, it would be the size of a brick and double as a space heater. The hardware fix for that physical constraint is gallium nitride, or GaN. Inside this casing, an 8th generation GaN chip is what allows the manufacturer to pack 120 watts into a footprint this compact. The main advantage of replacing silicon with GaN is thermal efficiency. It aggressively dissipates heat, keeping the surface temperature low even under maximum load. That thermal control is backed by multiple layers of active monitoring. This grid highlights the protections tracking temperature limits, over power jaws, and voltage spikes to prevent battery damage. The trade-off for shrinking the footprint and managing that heat is cost. GaN components are simply more expensive to produce than standard silicon. So the physical hardware is capable and safe, but its actual output speed is managed entirely by software protocols. Charging protocols are the language the charger uses to your device. The US8 supports major industry standards, protocols including the PD 3.1, the versatile PPS standard, and the UFCS protocol. Because it speaks these languages, it can communicate with proprietary fast charge modes across fractured ecosystems, whether you carry Samsung, Xiaomi, or Apple. This comparison graphic shows what happens when that handshake works perfectly. In 15 minutes, a standard 30-watt brick gets a compatible phone to 20%, while this 120-watt charger pushes it to 50%. But here is the major limitation. The charger can offer 120 watts, but the speed is strictly capped by the maximum intake your device allows. This matrix shows who benefits. Android flagships from Vivo and Huawei absorb massive power, hitting full charge under 25 minutes. At the bottom right, Apple caps the iPhone's intake much lower. Even on a 120-watt source, most of that capacity stays idle. A universal charger means it will safely charge anything you plug it into, but your specific phone model dictates the absolute speed limit. There's one more physical constraint to look at: the bridge between the brick and your phone. To pull maximum speed, you have to use a USB-C cable that is specifically rated for 120-watt throughput. If you swap in a cheap, unrated cord, the charger's protections will throttle your speeds down to prevent a fire, negating the benefit of the 120-watt brick. You also have to consider the layout. This is a single-port design. By only having one output, it dedicates all 120 watts to a single piece of hardware without the power-splitting interruptions you get from multi-port hubs. This forces a distinct lifestyle trade-off. You are choosing the absolute maximum charging speed for one demanding device over the daily convenience of plugging in your phone, watch, and earbuds at the same time. At the hardware level, this charger delivers. It is safe, incredibly powerful, and manages heat effectively. But the core rule remains: having 120 watts of power on tap is useless if your daily devices aren't built to accept it. This decision tree maps out if this is right for you. Do you charge a high-wattage laptop or Android flagship? If yes, it's a practical choice. But if you only carry Apple devices or multiple small accessories, you land in the mismatch category. Standard iPhones cap their intake around 27 watts. Buying a 120-watt single-port charger for an iPhone means paying for headroom you will never use. Only purchase a 120-watt GaN charger if your ecosystem supports high wattage intake. Otherwise, prioritize a lower wattage multi-port hub for better daily convenience.